It all started on a day like any other. Here at NASA's Goddard Space Flight Center, scientists were sipping their morning coffee. They were watching data stream in from the far reaches of our solar system. The James Webb Space Telescope, our golden eye in the sky, was performing flawlessly. It was sending back images that were rewriting textbooks and dazzling our imaginations. No one had any reason to suspect that this ordinary Tuesday would soon become a day etched in the annals of space exploration history. The mood was calm, almost routine, a testament to the incredible reliability of a machine operating a million miles from home. The universe was speaking, and we were listening intently. Then, the unthinkable happened. The steady flow of data, a constant digital heartbeat from the depths of space, suddenly stopped. On the massive screens at Mission Control, the telemetry flatlined. A collective gasp filled the room. Engineers frantically typed at their keyboards, running diagnostics and sending commands into the void. Was it a simple glitch? A temporary communication blackout? Hope was a flickering candle against a rising wind of dread. Every second of silence felt like an eternity. The most powerful telescope ever built, humanity's crowning achievement, had gone dark. It was a chilling, deafening silence that echoed from the cold, dark expanse between the stars. Panic began to bubble just beneath the surface of professional calm. The team ran through every possible scenario. They checked the Deep Space Network antennas. They rebooted ground systems. They sent signal after signal, pinging the telescope's last known coordinates. But the void offered no reply. It was like shouting a friend's name into a canyon and hearing nothing back, not even an echo. The silence was absolute. The JWST, a multi-billion-dollar marvel of engineering, had vanished without a trace. The weight of the moment pressed down on everyone in the control room. It was a crisis of unprecedented scale. Days turned into a week. The media caught wind of the story, and headlines around the world screamed the news. "Has NASA lost Webb?" one asked. "Our eye on the universe is blind," declared another. The public, which had fallen in love with Webb's stunning cosmic portraits, felt the loss personally. It was a shared grief for a machine that had become more than just a tool. It had become a symbol of our curiosity and our reach for the stars. Back at NASA, the grim reality began to set in. The James Webb Space Telescope wasn't just offline, it was lost, and the first clues pointed to a truly shocking and impossible culprit: Neptune. The initial shock gave way to a steely resolve. Losing the Webb was not an option. In a series of hushed, high-level meetings, a plan began to form. It was a plan so bold, so ambitious, it bordered on science fiction. They wouldn't just write off the telescope, they would go and get it. Or rather, they would go and fix it. The mission was codenamed Project Phoenix, a fitting name for an operation designed to bring our greatest asset back from the dead. The goal was simple to state but monumental to achieve. Send a robotic repair mission nearly 3 billion miles across the solar system to rendezvous with the silent telescope in orbit around the ice giant, Neptune. This was a mission of 1,000 challenges. First, there was the spacecraft. No existing probe was capable of such a journey on such short notice. Engineers from NASA, the European Space Agency, and private partners like SpaceX were brought together. They worked around the clock, cannibalizing designs from previous missions and inventing new technologies on the fly. They needed a craft that was fast, durable, and equipped with a suite of advanced robotic arms and diagnostic tools. It had to be a combination of a deep space ambulance and a highly skilled surgeon, capable of operating in the most extreme environment imaginable. Then there was the timeline. Every day that passed increased the risk of the Webb drifting into an unrecoverable orbit or sustaining further damage. The launch window was tight. The trajectory had to be perfect, using gravitational assists from Jupiter to slingshot the rescue craft toward Neptune at incredible speeds. The calculations were mind-bogglingly complex. A single miscalculation, even by a fraction of a degree, would send the probe hurtling into the empty void, missing its target by millions of miles. The pressure on the navigation teams was immense. They were charting a course to a needle in a cosmic haystack. Against all odds, Project Phoenix came together. In a record-breaking 10 months, the Stargazer rescue probe was built, tested, and prepped for launch. It was a marvel of international collaboration and sheer human ingenuity. As it stood on the launch pad at Cape Canaveral, gleaming under the Florida sun, it represented more than just a spacecraft. It represented hope. It was a testament to our refusal to give up, our determination to overcome any obstacle, no matter how vast. The world watched, holding its breath, as the countdown began for the most audacious rescue mission in human history. The journey to save the Webb was about to begin. The launch of the Stargazer was flawless. A thunderous roar tore through the sky as the powerful rocket climbed, pushing against Earth's gravity. It painted a fiery arc against the blue canvas of the atmosphere, a beacon of hope on its way to the outer solar system. For the mission control team, the relief was palpable, but it was only the first step in a very, very long journey. The Stargazer was now on its own, a solitary traveler embarking on a multi-year voyage through the cold and unforgiving vacuum of space. Its destination was a world so distant it appears as a mere speck of light even in powerful telescopes from Earth. The trip was a long and lonely one. Months turned into years. The Stargazer silently executed its pre-programmed maneuvers, its onboard computers guiding it through the vast emptiness. It passed the orbit of Mars, a dusty red marble. It navigated the asteroid belt, a cosmic minefield of rock and ice, relying on its advanced sensors to dodge any potential hazards. The team on Earth could only watch and wait, monitoring the probe's health from afar. They were like anxious parents, sending their child off on an impossible quest, able to offer support and guidance but powerless to protect it from the dangers of the unknown. The Jupiter flyby was the mission's first major test. The Stargazer needed to use the gas giant's immense gravity to slingshot itself toward Neptune, a maneuver that would shave years off its travel time. As the probe approached the colossal planet, it was battered by intense radiation and gravitational forces. The team held its breath as the spacecraft swung around Jupiter, its cameras capturing breathtaking images of the swirling Great Red Spot and the Galilean moons. The maneuver was executed perfectly. The Stargazer, now moving faster than any human-made object before it, was flung into the outer darkness on a direct course for the ice giant. After the Jupiter encounter, the silence deepened. The sun, once a brilliant star, shrank to a bright point of light, its warmth no longer reaching the probe. The Stargazer journeyed on through the orbits of Saturn and Uranus, a tiny, resilient emissary from a world of light and life. It was now in the realm of the ice giants, a cold, dark, and mysterious region of our solar system. The team on Earth continued its vigil, their hopes pinned on this lonely, robotic pioneer. Soon, it would approach its destination. It would finally reach Neptune and begin the search for the silent James Webb Space Telescope. After nearly 5 years of silent travel, the Stargazer probe finally entered Neptune's gravitational embrace. The mission had reached its most critical phase. The first task was to locate the Webb. Mission Control sent a command to the Stargazer to begin its search using a powerful wide-range scanner. The probe began to sweep the space around the blue planet, listening for any faint signal, any whisper from the lost telescope. The initial scans came up empty. For hours there was nothing but the background hiss of the cosmos and the faint radio emissions from Neptune itself. The anxiety in the control room was thick enough to cut with a knife. Just as hope began to fade, a blip appeared on the screen. It was weak, intermittent, and garbled, but it was there. It was a carrier signal, the digital ghost of the Webb's communication system. The telescope was alive. A wave of relief and excitement washed over the team. They had found it. The signal was traced to a low, unstable orbit around Neptune, dangerously close to the planet's upper atmosphere. The Webb was not just silent, it was wounded and trapped, slowly being pulled in by the ice giant's gravity. The rescue mission had just become a race against time. The Stargazer adjusted its course, carefully approaching the source of the faint signal. As it drew closer, its high-resolution cameras were able to get the first visual. The sight was both horrifying and awe-inspiring. There was the James Webb Space Telescope, its iconic golden mirrors still gleaming, but it was tumbling slowly through space. One of its massive sunshield layers was shredded, flapping like a tattered flag in the solar wind. A long, dark gash was visible along the side of the main spacecraft bus. It was clear that the telescope had suffered a catastrophic impact. It was a miracle it had survived it all. The Stargazer began a detailed scan, circling the wounded giant like a careful medic examining a patient. It used its suite of instruments to assess the full extent of the damage. The data that streamed back to Earth painted a grim picture. Multiple systems were offline. The main antenna was misaligned, the propulsion system was leaking fuel, but beneath the damage, the core of the telescope, the precious scientific instruments and the primary mirror appeared to be intact. There was a chance, a slim chance, that it could be saved. The real work was about to begin. The stargazer prepared to get closer. With the Webb located and partially assessed, the next burning question was, what happened? How could the most advanced telescope ever built collide with a planet? It just seemed impossible. The stargazer's first mission was to play detective. It carefully maneuvered around the tumbling telescope, its cameras and sensors documenting every dent, every scratch, every piece of torn metal. The team on Earth pored over the high-resolution images looking for clues that would help them piece together the final moments before the catastrophe. They were searching for the ghost in the machine that led to this disaster. The investigation focused on the Webb's flight recorder, its so-called black box. The data was corrupted, but brilliant engineers worked tirelessly to recover fragments of information. Slowly, a timeline began to emerge from the digital wreckage. They discovered that the telescope had suffered a complete and sudden system failure. The main computer, the navigation system, and the communication array had all gone dark simultaneously. It wasn't a gradual decline, it was as if someone had simply flipped a switch. This pointed away from a simple mechanical failure and toward something far more unusual and powerful. The breakthrough came from an unexpected source: the debris field around the telescope. The stargazer's sensors detected microscopic particles embedded in the gash on the Webb's side. The material composition was unlike anything they expected. It wasn't from a micrometeoroid or a piece of space junk. Spectrographic analysis revealed a complex crystalline structure, rich in frozen methane and nitrogen, with exotic isotopic ratios. The signature was a perfect match for one thing: the material from Neptune's faint dusty rings. The Webb hadn't just collided with a random object, it had plowed through one of Neptune's rings. The final pieces of the puzzle fell into place. The system failure wasn't the cause of the collision, it was the result. A powerful localized electromagnetic pulse, originating from Neptune's bizarre and tilted magnetic field, had washed over the Webb. This pulse, a natural phenomenon of the ice giant's magnetosphere, completely fried the telescope's unshielded electronics. Blind and powerless, the Webb continued on its trajectory, drifting silently until it tragically intersected with the inner Adams ring. The impact with a larger-than-average chunk of ring material caused the physical damage. It was a perfect storm, honestly, a 1,000,000,000 shot of cosmic bad luck. Now that they knew what they were up against, the mission's complexity skyrocketed. The Webb was caught in a decaying orbit, meaning it was slowly but surely being dragged down into Neptune's atmosphere. To perform the repairs, the stargazer would have to fly in close formation with the tumbling telescope, a delicate ballet in a treacherous environment. This orbit took both spacecraft perilously close to the top of Neptune's clouds, a region of unimaginable violence. They were basically about to fly into the belly of the beast, a world known for having the fastest, most ferocious winds in the entire solar system. These are not winds like we know on Earth. On Neptune, winds whip through the upper atmosphere at supersonic speeds reaching over 1,200 miles per hour. They generate massive, continent-sized storms that can appear and disappear in a matter of hours. One of these storms, dubbed the Great Dark Spot, was a vortex so large you could fit the entire Earth inside it. The stargazer and the Webb would have to navigate through this chaotic weather system. The mission planners on Earth used data from the stargazer's sensors to build predictive weather models, trying to forecast the planet's fury and find brief, calm windows to conduct their work. The first attempt to stabilize the Webb was a harrowing experience. As the stargazer extended a robotic arm to gently grab onto the telescope's frame, a sudden violent updraft from the atmosphere below caught them by surprise. The two spacecraft were tossed about like toys. Alarms blared in mission control as the stargazer's thrusters fired furiously, fighting to maintain a stable position. For several tense minutes, it was unclear if the probe could escape the atmospheric turbulence. The team on Earth could only watch their monitors in horror, their hearts pounding as they listened to the frantic telemetry data. Miraculously, the stargazer's pilots, both the AI on board and the human controllers billions of miles away, managed to pull the crafts back up to a safer, slightly higher altitude. The event served as a stark reminder of the dangers they faced. They were operating on a knife's edge, where a single mistake or a moment of planetary wrath could doom the entire mission. Every subsequent approach would have to be planned with even greater precision. They weren't just fixing a telescope, they were doing it while surfing the edge of a supersonic hurricane on a world of ice and gas. With a clearer understanding of Neptune's volatile weather, the team developed a new strategy. It was a daring dance of precision and timing. The stargazer would dip into the more turbulent regions only for short, calculated periods, performing one critical task at a time before retreating to a safer altitude. The first order of business was to stop the Webb's uncontrolled tumble. Using its delicate but powerful robotic arms, the stargazer gently attached itself to the telescope's main structure. Then, with carefully controlled thruster bursts, it slowly and methodically arrested the spin, until the wounded giant was finally still. Once the Webb was stabilized, the real surgery began. The stargazer's robotic arms, equipped with a suite of specialized tools, became an extension of the engineering team on Earth. There was a significant time delay. It took over 4 hours for a signal to travel from Earth to Neptune, so the robots had to be given a degree of autonomy. The team would upload a sequence of commands and the robot would execute the task, using its own sensors to make micro-adjustments. It was like performing remote surgery on a patient from across an ocean, with a 4-hour lag on every movement. The list of repairs was long and daunting. One robotic arm carefully cut away the shredded, useless section of the sunshield. Another, equipped with a sophisticated welding tool, meticulously sealed the long gash on the spacecraft's bus, patching the hole to protect the delicate electronics inside. The most complex task was realigning the main communications antenna. The arm had to gently nudge the massive dish back into its correct position, a movement of mere millimeters that required incredible finesse. All the while, the team had one eye on the repairs and the other on Neptune's weather, ready to abort and retreat at a moment's notice. Finally, the moment of truth arrived. The physical repairs were complete. Now it was time to see if the Webb's brain could be rebooted. The stargazer connected a power and data cable to the telescope's service port, essentially jump-starting it. The team on Earth sent the reboot command. For long, agonizing minutes, nothing happened. Then, a single packet of data appeared on a screen in mission control. It was a simple system diagnostic, but it was the most beautiful signal they had ever seen. The Webb was back online, its systems were booting up, the ghost in the machine had been exorcised. The revival of the James Webb Space Telescope was celebrated around the globe. It was really a story of triumph over adversity, a stunning display of human ingenuity and international cooperation. But the mission wasn't over. The Webb was now in a stable orbit around Neptune, a planet it was never designed to visit, let alone study up close. The team realized they had a unique, once-in-a-lifetime opportunity. Instead of attempting a risky and fuel-intensive journey back to its original position, they decided to embrace the unexpected. The Webb would begin a new mission as Neptune's personal observatory. The first images that came back were nothing short of revolutionary. Freed from the sunshield that was now partially removed, the telescope's sensitive instruments were able to stare directly into the cold heart of the ice giant. It captured the planet's faint, dark rings in breathtaking detail, revealing intricate structures and clumps that had only been theorized before. The telescope's infrared eyes peered deep beneath the methane clouds, mapping the planet's internal heat and weather patterns with a clarity that was previously impossible. We were seeing a whole new side of Neptune thanks to a near catastrophe. The discoveries kept pouring in. The Webb studied Neptune's largest moon, Triton, a captured object from the Kuiper Belt. It analyzed the geysers of nitrogen gas erupting from Triton's icy surface, providing new insights into the processes that drive cryovolcanism. It discovered a dozen new tiny moons orbiting the planet, small chunks of ice that had evaded detection until now. The telescope that was built to look back at the dawn of time was now giving us an unprecedented look at the mysterious outer reaches of our own solar system. It was a beautiful and unexpected second act for the world's greatest space observatory. In the end, the collision that almost destroyed the James Webb Space Telescope led to one of the greatest periods of planetary discovery in modern history. The story of Project Phoenix and the Stargazer became a legend, a symbol of our resilience and our unyielding drive to explore. It taught us that sometimes our greatest triumphs can emerge from the ashes of our most profound failures. The Webb, our wounded warrior, continued its lonely vigil in the deep blue twilight of Neptune's orbit, a testament to the idea that even in the face of disaster, the human spirit and our quest for knowledge will always find a way to reach for the stars.